Hi everyone, just a very quick video here on using logic gates on Falstad.com. And here we see some very basic logic gates. We should have seen this in the lecture before you watch this video, but in case you're watching this in advance, then first, well done. Second, let's learn quickly about what those logic gates are. The first one we have here is the OR gate, which means its output is going to be the result of one input or the other. That means if I have low or low, if you only have those two options, your result will always be low. But then if you have high or low, your result will be high. That means I am adding. Basically, this is a sum. So 1 plus 0 is 1, 0 plus 0 is 0. 1 plus 1 is 1, and 0 plus 1 is 1. So this is your basic logic gate, the OR gate. When you have, instead of things being curved, you have it straight like this, you have the AND gate. And with the AND gate, the result will only be true, will only be high, will only be 1. So true, high, 1, low, 0, false are the same thing. So the AND gate is basically the multiplication. So if I have 1 times 1 equals 1. 1 times 0 is 0. 0 times 1, or 1 times 0, sorry, the opposite one is also 0. And then if I have 0 times 0, it is also 0. So the only way the output of an AND gate is true is when both or all the entries, you can have more than one, is positive. Sorry, is true or high or 1. See here that I can change the number of inputs. So just to show you here, I'm going to come to draw, logic gates, and I'm going to put an AND gate. I will put it here. I'll press I for logic input, and I'm going to drag from, oops, press the wrong button. I thought I had this one covered. I, what is happening? Draw, is my keyboard working? Yes, it is. So press I. Yeah, okay, I don't know what is happening anymore. Draw, input source, and logic gates, add logic input. Oh, sorry, my caps lock. I think my caps lock was on, or that must have been it. So I'm going to drag here low, low. I press O for output, and I have it here as low. The moment I click and click, they become high. But if I double click here and choose the number of inputs equal to 4, and I add more logic inputs here, then we see that the output is low. It is still low. It will only be high when all the inputs are high or true or 1. On the next one, we have the XOR gate. This is a very important one as well. And XOR stands for exclusive OR. That means that the output is only true only when one input or the other is true. So here you have low and high, output high. Low and low would be low, and high and low is also high. But if I turn this guy on, you see that the output is low because this is an exclusive OR. Either one of those needs to be true for this output to be true. If this and this are on, unlike the AND and the OR gate, you see here that the output is low. And on the other hand, we have the NOR gate, which means like negating OR. You'll see this circle right in here. That means that I'm inverting the result of my OR gate. So low and low would be low, sorry, low or O. Low would be low, however, I'm inverting this low here, becoming high. And if I turn one of them, so 1 plus 0 is 1, inverting 1, 0. 1 plus 1 is 1. In this case here is not 2, but the output should be 1, should be true. I'm inverting the output here with the circle, and it's low. And the same goes for the NAND gate or not AND gate. And therefore I have here high and high should be high, but I'm inverting here, and I have low. And if I have 0 and 1 would be 0, I'm inverting, it is 1. And 0 times 0 is 0, I'm inverting, and it becomes 1 as well. So as you see, logic gates, they are not very difficult circuits. We can do a lot of things with it. We should have seen this in the lecture. And this is basically, this is how you put logic components into Falstad. It is nice because it is interactive. So LT-Spice is very powerful, but this interactivity here is very nice to have. And if you come here to circuits, and we come to logic families, nope, where are they? Passive filters, it's not what I'm looking for. Combinational logic. So you can see here that I'm going to create a new blank circuit. And if I come to combinational logic and create a half adder, it is going to create a circuit that does addition. So you see it right here. It is it is different from what you would think, right? Because half adder, I'm adding, so I would use OR gates, use an AND gate, which will be the carry. So if I have 1 plus 1 is 2, but I can only represent one bit. So the carry would be the next bit that represents the 2. And here we have, so 0 plus 0 is 0. 0 plus 1. 1 plus 0 is 1. 1 plus 1 is 2. So I have here my bit 1 and 2. This is the carry bit. So you see how you can assemble circuits to do things with logic gates. If I come here again and create a full adder, you see that now I will have here, this would be my carry, and this would be my input. So I can keep things going in here. And if I have 1 plus 1 plus 1, it's 3. This in binary is equal to 3. And this is it. This is just a simple demonstration of logic gates. This kind of thought for logic gates is what we use when you're doing if, else, or those while the conditions that we work on in programming. So it is very important to understand them well. So whenever you're creating conditions in your code, you have it well established in your mind what is happening behind the doors. All right, this is it. Quick video. I hope it was quick. I will see you in the next one. Bye bye.